Have you ever felt the frustration of learning something new, only for it to vanish from your mind just hours or days later? You study for a test, attend a lecture, or read a book, and then, poof, the details are gone. It's a universal and often maddening experience. Why does our brain seem to betray us, erasing information we've just worked hard to acquire? Is it a flaw in our memory system, or a fundamental, perhaps even beneficial, process? Prepare to uncover the astonishing science behind forgetting as we dive deep into the fascinating world of neuroscience and psychology to reveal why your brain lets go of information. Stay with us until the very end to learn how you can fight back against the forgetting curve. Welcome to Young Curiosity, where we explore the mysteries that shape our world. If you're fascinated by the incredible complexities of the human mind, you're in the right place. Please take a moment to smash that like button, subscribe to Young Curiosity for more mind-bending insights, and tell us in the comments where you're watching from. Your support helps us bring these incredible topics to life. Before we explore why we forget, let's understand how we learn and remember in the first place. Memory isn't a single monolithic system. It's a complex multi-stage process involving different types of memory. First, we have sensory memory, which acts like a momentary snapshot, capturing information from our senses for mere milliseconds. Think of the afterimage of a flashbulb or the brief echo of a sound. It's there, then it's gone, unless you pay attention. If we do pay attention, this information moves into short-term memory, often called working memory. This is your brain's temporary notepad holding a small amount of information, typically about 5 to 9 items, for a brief period, roughly 20 to 30 seconds. This is where you hold a phone number someone just told you, or the start of a sentence as you're reading it. If this information isn't actively used, rehearsed, or deemed important, it quickly fades, never making it to long-term storage. Finally, if something is truly important, it undergoes a process called encoding and gets transferred into long-term memory, where it can potentially reside for a lifetime. But even these permanent memories aren't always so permanent. What's the most random fact you remember from childhood? Share it below. One of the most famous models is the forgetting curve, pioneered by German psychologist Hermann Ebbinghaus in the late 19th century. Ebbinghaus conducted groundbreaking experiments where he memorized lists of nonsense syllables and then tested his recall over various periods. His findings were revolutionary. We rapidly forget new information, especially very soon after learning it. He famously demonstrated that within just an hour, we can forget over half of what we've just learned, and after a day, retention can drop to as low as 30%. This iconic curve illustrates that forgetting is not a linear process. It's steepest right after initial learning and then gradually levels off. This means those initial hours after studying something new are absolutely crucial. If you don't reinforce information quickly, your brain starts discarding it almost immediately, much like clearing temporary files. This is precisely why cramming for tests often leads to poor long-term retention. The information is never given a chance to properly consolidate. So, why does this rapid decay happen? One primary reason is encoding failure. This isn't actually forgetting. It's more accurately described as never truly remembering in the first place. We often deceive ourselves into thinking we're learning when we're merely being passively exposed to information. If you're distracted by your phone, multitasking between assignments, or simply not actively engaged with the material, the information might never properly transition from short-term to long-term memory. It's like trying to save a crucial file to your computer without ever hitting the Save button. The data flashed on the screen momentarily, but it was never properly written to the hard drive for long-term storage. True encoding requires attention, active processing, and often making meaningful connections to existing knowledge. Without this deep processing, where you truly think about, organize, and integrate the information, The connections in your brain are too weak to stick. Another major culprit is storage decay. Even if information is successfully encoded into long-term memory, it can still fade over time if not regularly accessed or reinforced. Think of an old, seldom used path in the woods. If no one walks on it, it eventually gets overgrown and disappears. Similarly, the neural connections or synapses that form the physical basis of our memories can weaken if they're not used. This use it or lose it theory suggests that memories simply degrade or decay spontaneously with the mere passage of time, especially if they are not reactivated. While appealing in its simplicity, storage decay alone doesn't fully explain all instances of forgetting. Our brains are incredibly dynamic and constantly active, and it's rare for memories to simply vanish without some form of interference or active suppression. This brings us to interference theory, which argues that forgetting occurs primarily because other memories get in the way. Our brains are constantly bombarded with new information, creating a dynamic and sometimes competitive environment for existing memories. There are two main types of interference: proactive interference and retroactive interference. Proactive interference happens when old memories interfere with your ability to recall new ones. For example, if you've recently changed your phone number, your old number might persistently pop into your head when you try to dial the new one. The old memory is proactively disrupting the new. Retroactive interference, on the other hand, occurs when new memories make it harder to recall old ones. Learning a brand new programming language, for instance, might make it harder to recall specific syntax or vocabulary from a language you learned years ago. The new learning is retroactively interfering with the old. Our brains are constantly processing new information, forming new connections, which can sometimes lead to confusion and competition between different memory traces. Beyond these established theories, fascinating new research suggests that forgetting isn't just a passive failure of our memory system. It can be an active, adaptive process, crucial for brain efficiency. This idea is sometimes called adaptive forgetting or memory pruning. Imagine your brain as a massive, constantly evolving hard drive. If it stored every single piece of data, every fleeting thought, every mundane detail, every irrelevant observation, it would quickly become overwhelmed, cluttered, and incredibly slow. Forgetting, in this view, allows the brain to selectively declutter, prioritize, and focus on information that is most relevant, useful, and frequently accessed for current and future tasks. It helps us avoid mental overload and makes it easier and faster to retrieve truly important memories by reducing noise. Forgetting, then, isn't a bug. It's a sophisticated feature that keeps our cognitive processes streamlined and efficient. Do you think forgetting is a feature or a bug in our brain? Tell us what you think. The role of sleep in memory consolidation is also absolutely critical. While you're sleeping, your brain isn't just resting, it's incredibly active, engaging in crucial processes to consolidate memories from the day. During various sleep stages, your brain actively replays neural activity from waking experiences, strengthens important connections, synaptic potentiation, and prunes less important ones, synaptic downscaling. This is essentially your brain saving and optimizing the information you've learned. Lack of adequate and quality sleep can severely impair this consolidation process, making it much harder to retain new information. So, pulling an all-nighter before a test might actually be counterproductive. Your brain doesn't get the necessary chance to properly save what you've learned. Quality sleep is, therefore, foundational for efficiently moving information from short-term to long-term memory. Furthermore, the context in which we learn information plays a huge role in our ability to retrieve it later. If you learn something in one specific environment, say, a quiet, dimly lit library with a particular background scent, and then try to recall that information in a very different context, like a noisy, brightly lit exam hall, filled with other students, you might struggle more than expected. This phenomenon is known as context-dependent memory. Our brains implicitly link memories not just to the information itself, but also to the sensory cues, emotional states, and physical environment present during the encoding process. When those cues are absent during retrieval, accessing the memory becomes more difficult, almost as if the trigger is missing. This principle is why revisiting an old childhood home or a place you haven't seen in years can sometimes trigger vivid, detailed old memories you thought were lost forever. So, how can we fight the forgetting curve and improve our memory? The good news is, understanding these complex mechanisms gives us powerful evidence-based strategies. Spaced repetition is one of the most highly effective methods. Instead of cramming information all at once, review it at increasing intervals over time. This consistent spaced exposure actively strengthens neural pathways and signals to your brain that the information is important and needs to be retained long-term. Active recall, testing yourself, is far superior to passive rereading. When you force your brain to retrieve information from scratch, you actively strengthen the memory trace and identify gaps in your knowledge. Engaging multiple senses during learning, explaining concepts to others in your own words, and making emotional or personal connections to what you learn also significantly deepens encoding. Finally, prioritizing quality sleep, as we discussed, and effectively managing stress, which can impair memory function and focus, are absolutely crucial for optimal brain performance and memory retention. Ultimately, forgetting isn't just a nuisance or a sign of a failing memory. It's an essential, dynamic, and incredibly sophisticated process that allows our brains to remain efficient, adaptable, and focused. By understanding why we forget, we gain powerful insights into the intricate workings of our memory and, more importantly, how we can optimize it to better serve our learning goals. Our brains are truly incredible biological machines, constantly balancing the critical need to retain vital information with the necessary process of letting go of the irrelevant to prevent cognitive overload. The journey to mastering your memory begins with understanding its hidden secrets. What strategies do you use to remember new information? Share your tips in the comments below.